Hi, seventh graders. This is just going to be a video to kind of go over percent change and percent error and how you can solve problems using our percent proportion, just kind of tweaking that a little bit. So quick review of our percent proportion. Remember, we've been dealing with our part over our whole equals the percent over 100. So our whole unit is over percents. Every time you hear percent, percent means per 100. So your percent will always go over 100. So we've been using this proportion a lot. And then I just also want to remind you that even if you're completely stumped and you don't know what to do, this is usually a good starting point. Okay, and then you're starting to fill in that proportion. So what we're going to do is we're actually going to tweak this percent proportion to help us solve for percent change and percent error problems. So percent change describes how much a quantity has changed relative to its original amount. So you're always going to be comparing to an original amount. And so this example is showing we have an alligator that was 32 inches last year and 38 inches this year. And so we want to figure out the percent of change in the alligator's length. Okay, so we're going to base it off. We're going to use this part whole proportion, percent proportion, but we're going to tweak some things slightly. Okay, so now our part is actually going to be represented by the amount of change between the two numbers. And that whole will be the original number. And so we're still going to have percent over 100. So even if we have no idea where to start, we can set up that proportion with that 100 as a denominator. So this particular problem, I'm trying to solve for the percent of change. So that means that I don't know the percent, so that's my variable. My original number is the whole number. So these percent of change problems are normally going to be some reference of time. So comparing last week to this week, or comparing 2019 to 2020, or last year to this year. And so whichever number happens first is your original number, okay? And so in this example, that 32 inches last year, so the 32 is our original number there. So again, it's not something like it's always the smaller number or it's always the larger number. It's whichever number happened first. And so then our part is actually going to be represented by the amount of change. So we grew from 32 inches to 38 inches. And so we actually grew an extra 6 inches over that time. So 6 inches is our part now. And so now we have our proportion, and now we're able to go ahead and solve that. So remember, there's a variety of ways that you might choose to solve your proportion. There's a couple of different strategies you could use. One of those strategies would be cross products. So knowing that 6 times 100 is going to equal the same thing as 32 times x. And so we can go ahead and divide 600 by 32. And to figure out that our x here is going to equal 18.75. And then because we're solving for the percent of change, we want to make sure we put that percent symbol on there as well. So what this means is the alligator's length increased by 18.75% of its original length of that 32 inches. So here's another example. Remember, we can always start off with, even if we have no idea what we're doing, this should always be on our paper or on our whiteboard or on our desk somewhere as our starting point, okay? So last year our website had 40,000 visitors, and this year it had 37,000 visitors. What's the percent change in the number of visitors to the website from last year to this year? So again, we're solving for the percent, okay? The question is asking what's the percent. That it means that we don't know the percent, so that's what we're solving for. Our original number is going to go on the bottom. And so in our original, meaning whichever one happened first, okay? And so in this case, it says last year there were 40,000 visitors. So 40,000 goes on the bottom as our denominator. And then we just have that one extra step where our part is now the amount of change between the two numbers. So we were at 40,000, now we're at 37,000. So we have to actually subtract them, okay? So when we find the amount of change, we want to find the difference between 40,000 and 37,000. And so some of you might be able to do that in your head, but our amount of change then is 3,000. And so then that becomes our numerator here. From here, again, a variety of ways to solve the proportion. You can use your cross product method. Some of you might see a relationship here, okay? So 40,000 divided by 400 would give you 100. So I can divide by 400 up here. Or you can use the cross product method. Both ways should give you an answer of 7.5. And again, on this one, we were solving for the percent of change. So this would be 7.5%. So and this was a decrease. So decrease meaning our number of visitors went down. We can also use that same percent proportion and kind of tweak it to help us find percent error. So percent error is just describing the accuracy of someone's estimate compared to an actual value. So here, Sean estimated that the attendance at a college lacrosse game was 3,000. The actual attendance was 3,296. What's the percent error of Sean's estimate? And round to the nearest whole percent. So we're still starting off with that same proportion. All right, we're solving. The question is asking what's the percent error. So that means we don't know the percent yet. We're going to put the actual amount as our original or as the whole. And so the actual attendance was 3,296. So that tells us that this number goes here. And then our part is going to be represented by the difference between the estimate and the actual. So how far off Sean was. And you just always want to take the higher one minus the lower one. So the actual attendance was 3,296. Sean estimated 3,000. So the difference there is 296. So then this is our proportion. When we solve this, notice in the question it says round to the nearest whole percent. So math isn't always pretty. We're not always going to get nice round numbers. So when we solve this, again, using a variety of proportion solving strategies, you end up getting kind of a crazy decimal. First couple of numbers are 8.98, and then there's a whole bunch of repeating digits as well. So we want to round to the nearest whole percent. So I want to know, is this closer to 8% or is it closer to 9%? And if we round to the nearest whole percent, we're going to see that it's closer to 9%. So that means Sean's estimate was about 9% off. So here's another percent error problem. Okay, so again, we're going to do use that proportion like this. Our actual number will always be the actual, or the original is always going to be the bottom, the denominator, and then the top is going to be the difference between those two numbers. So the specification for the length of a bolt is 4.75 inches. A machinist makes a bolt that is 4.769 inches long. What's the percent error of the bolt's length? And so when we solve that, we can see that the actual bolt ended up being 4.769 inches long. We're solving for the percent. And so our numerator here then is going to be the difference between what it should have been and what it actually was. Okay, and so if we subtract, the 4.769 minus the 4.75, you guys can always use your calculators for this as well. You're going to end up with 0.019. So this is our part, okay, that difference between those two numbers. And again, we have our actual number as the denominator. So from here, we can use our cross products to solve. So I know that 19 thousandths times 100 is going to equal the same thing as 4.769x. And when I multiply, I'm going to get 1.9 is equal to 4.769x. And I can divide. And we're just going to round this to the nearest tenth. And so this is going to end up being about 0.4%. So again, your math isn't always going to be pretty. So it ends up being kind of a crazy number, and that's okay. So to summarize, when we're talking about percent of change, we're tweaking that percent proportion. So the part is now the amount of change between two values. The whole is always the original value or the original amount. And that's going to be equal to the percent over 100. And so your percent could be a percent of increase, meaning your value goes up, or it could be a percent decrease, which means it goes down, okay? Percent error, same idea. You're going to have the difference in your amounts over the actual amount. And then that's going to be equal to your percent over 100. All right, have a wonderful day.